Nuclear chemistry, introduction, goals, and review. The purpose of this podcast is really just to give you a brief introduction to what we're going to talk about in this chapter and what the goals of this chapter really are. We'll be talking about nuclear decay, fusion and fission, the relationship between mass and energy, and lots of interesting applications along the way. By the time we're done, we will have explained various types of nuclear medicine that's in use, smoke detectors, Geiger counters, nuclear bombs, nuclear power, and how we can radioactively date things. There's one quick thing that I want to review with you, and this you should have covered at various points throughout your high school or 1P career, but let's go over it a bit now too. And this is how you talk about symbols when you need to be very specific about the isotope. Your X here, just like normal when you write a chemical symbol, is the 1 or 2 letter symbol from the periodic table. A is your mass number. This is your number of protons and neutrons added together. So it gives you an approximate mass for the atom. Z is the atomic number, or in other words, the number of protons. When we're talking about beta particles, which you can think of for right at the moment as electrons, we'll be actually putting its charge down as Z rather than its atomic number, since it doesn't actually have any protons. And this will allow us to do charge balances across equations. It's also, you should note, since this is protons plus neutrons and this is protons, you can find your number of neutrons by taking your mass number minus your number of protons. Let's do a couple of examples. Let's start with lithium. For each one, we'll talk about the number of protons, neutrons, and just for good sake, electrons. So here we have a mass number of 7, an atomic number of 3. And so we know that there are 3 protons, which means that there's also 3 electrons since it's neutral. And since there's 7 total mass units, that means that we must have 4 neutrons. In other words, 7 minus 3 equals 4. Let's do the same thing for boron. We have a proton number of 5, which means that we also have 5 electrons. And we can calculate our number of neutrons by taking our 8 minus our 5 to get 3 neutrons. For our last example, we'll do a heavier atom. We have a mass number of 235 and an atomic number of 92. This means that we have 92 protons and also 92 electrons, since those are equal as long as you don't have a charge. And then we'll take our 235 minus our 92 to give us 143 neutrons. This is really the biggest piece of introductory material that you need to make sure that you can do before moving on. And with that, we'll end the introductory video.